Hi, in this video what we're going to do is we're going to calculate binomial probabilities using what's known as a cumulative distribution function as opposed to just using the probability density function. So the random variable x belongs to a binomial distribution with n 16 and the probability of success is a half. Using the cumulative distribution function, find a probability that x is less than or equal to 8, b probability that x is less than 5, and b probability that x is greater or equal to 12. Okay, so we've got x belonging to binomial n 16 and a half, and we want the probability that x is less than or equal to 8. If we go to our computer and open up a GeoGebra, okay, and then go straight away to view and go to probability calculator and enlarge that, and then what you need to do first of all is move this up a little bit, otherwise you won't get the parameters, and then go to binomial. Okay, we got n was 16 and the probability of success is half. But enter and then we get all the probabilities. Okay. In the first instance, we wanted that x is less than, so if we click this one and put less than 8 and press enter, okay, what we need to do is we need to calculate the sum of all these rectangles here, which we can do by adding up these probabilities. However, there is a function which is called the cumulative distribution function, where what it does is it adds up all the probabilities like you do for cumulative frequency. Alright, so for example here we have all the ones which are less than 6. Okay, for the ones that are less than 8 we need to take this height here, and what we got here is a table of values, and it gives me the answer straight away, 0.59882. So this is the probability of x being equal to 0, 1, 2, 3, 4, 5, 6, 7 and 8. So it gives me up to a point. So this one here gives me all the values from 0, 1, 2, 3, 4, 5 and 6. This is how it works. It's called the distribution function, and you normally get a set of tables, or you get a calculator which will calculate the PDF and the CDF. What you need to do is understand the difference between the two. We're not really interested in the shape of the function. So, using the probability density function, PDF, we want the area of those shaded ones. So what we're trying to find is we need to sum all these. Alright, however, if we use the cumulative distribution function, CDF, we get a set of tables here, and this tells me this value here, 8, 0.5982, gives me all the values between 0 up to 8. So all I need to do is just take that value from the table. Okay, so the probability that x is less than 8, less than or equal to 8, is 0.5982. Normally we'd round that off to 3 significant figures, so 0.598 to 3 significant figures. Okay, to the second one, part B, probability that x is less than 5. So we go back to this. Okay, let's just go back to the PDF to begin with, and in here we don't put 5 because we want less than 5, so we don't include 5, so we want less than or equal to 4, which is going to be the area of those three there. So what we'd do, we'd have to add up all those. However, if I click this one here, we get the CDF, and then all I need to do is, that does sum up all the 1, 2, 3 and 4 from the other table, so we get the answer straight away, 0.0384. So going back to so what we need to do is look at the probability x is less than or equal to 4. Using the PDF you get this. Okay, but that means you'd have to add up all these on a calculator. Not impossible, but it involves a little bit of work. However, if we use the CDF table, we get the value straight away, because the 0.384 is the sum of all those. So we can write down the probability x less than 5 is equal to 0.0384, and that's already correct to three significant figures. Okay, last one, where x is greater than 12. Going to, I think, let's just go back to this. So in here, greater than here we just put in 12. So what we want is that area, that area, that area. Now, if we're going to use the CDF, we need to be careful, because what we need to do, CDF gives from 0 up to a point. So what we have to be careful is that we know from here to 16, the total area will be 1, or the total sum of these rectangles is 1. So what we need to do is do 1 take away being less than or equal to 12. Okay, so you got that clear? So in order to do greater than or equal to 12, we need to do up to 1, taking away all the ones less than or equal to 11. Okay, so if we go to the CDF in here, we need to put in 11. Okay, so we're going to need to do 1 minus that number there. So going back to this, using the PDF, we need to sum those rectangles up. Okay, but we're trying to do this, we're using the cumulative distribution function, so we need to look up what 11 is. So that gives me the area from all the way up to there to here. And therefore the probability that x is greater or equal to 12 will be 1 minus the probability that x is less than or equal to 11. This is what you have to do if you're using the CDF. Okay, so that's going to be 1 minus 0.9616 from the table, which again gives me 0.0384 from two three significant figures. Okay, so it's been a video to show you how to use the cumulative distribution function to calculate binomial probabilities. I hope you've understood, and I thank you very much for watching.